Students, let us see now some important questions and expected questions from periodic table, periodic classification of elements. Let us see the question number 1. Which of the following is correct set of ionization potentials? Ionization potential, which is among these given, let us see correct set. Option 1 is given as IP1 of nitrogen is more than IP1 of oxygen. Suppose we talk about nitrogen, electronic configuration coming to be S2P3. Oxygen electronic configuration is coming to be S2P4. It is having stable configuration with P3, therefore IP1 of nitrogen is more than IP1 of oxygen. We agree that. Coming to second, IP2 of oxygen is more than IP2 of nitrogen. IP2 of oxygen, suppose O plus to talk about. O plus will be one electron lost from here, then it will be S2P3, then consider nitrogen N plus, then it will be S2P2. Then IP2 of O plus or IP2 of oxygen, you see, IP2 of oxygen is greater than IP2 of nitrogen. That is also correct. See option 3, IP1 of beryllium is more than IP1 of boron. See now beryllium, the electronic configuration of beryllium is what, S2. But to say boron, this is what, S2P1. Then it is actually more than boron. Yes, we agree. The removal of electron from S2 is difficult, but we can easily remove the electron from P1. Therefore, this is also a correct statement. Coming to option 4, IP2 of boron is more than IP2 of beryllium. IP2 you talk about, let us say boron plus, right? Then it is what, S2P0, and IP2 of beryllium you talk about beryllium plus, then it will be S1. Definitely this is S2 configuration, this is S1 configuration, therefore the second IP of boron is more than second IP of beryllium. So all the options whatever are given, all are found to be correct. Therefore question number 1, all are correct answers. So question number 1, answer is D. Look here, question number 2, rubidium electronegativity is 0.8, then the bond formed between rubidium atoms could be 0.8 electronegativity. See, whenever the generally metals are having low electronegativity, non-metals are having very high electronegativity. Whenever the electronegativity is very less, they are metallic. So metal atom to metal atom, there will be a metallic bond. Therefore option A is ionic, option B is what, hydrogen bond, option C is what, metallic bond, option D is van der Waals force he has given. But rubidium metal to rubidium metal and electronegativity less he has given, rubidium metal to rubidium metal, generally there will be a metallic bond. Therefore question number 2, answer is C. Question number 3, the electronic configuration of an element is 1s2, 2s2, 2p6, 3s2, 3p3. 2s2, 2p6, 3s2, 3p3. See how many electrons, check it, 15 electrons. Then 15 electrons means Z is equal to 15, that will be phosphorus. What is the atomic number of the element which is just below the given element in the periodic table? Suppose this particular phosphorus belonging to 50th group. 50th group elements should write nitrogen, phosphorus, arsenic, antimony, bismuth, let us take. According to this particular given configuration, atomic number coming to be 15. Then this is what, phosphorus is 15. Then arsenic coming to be what, 33. So below this particular element phosphorus, the next element coming to be arsenic. Arsenic atomic number is 33. Therefore question number 3, answer is A. Question number 4, which of the following grouping represents a collection of isoelectronic species? Isoelectronic species. Isoelectronic. Iso means same. Electronic means number of electrons. Iso means same. Electronic means electronic number and which are having same similar electronic configuration. That species we call it what? Isoelectronic species. It may be a pair of ions. It may be more than 3 or more than 2 or like that. Whichever are carrying same number of electrons, their configuration will be same. They are known as what? Isoelectronic species. Let us see the given options now. Option A is given as Ca plus 2, cesium plus 2, Br. What is given? Ca plus 2, cesium plus 2, simply Br. Atomic number of calcium is 20. The number of electrons here is what? 18. It is 55. Therefore, it is becoming 53. Bromine as such is given. Bromine atomic state. Atomic number is what? 35. Coming to option B. Na plus, Ca plus 2, Mg plus 2. Na plus, Ca plus 2, Mg plus 2. Number of electrons is 10. Number of electrons it is 18. Number of electrons it is what? 12. C. So this particular grouping is not carrying same number of electrons. This is also not carrying. You are observing that this particular also not carrying same number of electrons. Coming to options C, N minus 3, F minus, N minus 3, F minus, and Na plus. N minus 3 means 10 electrons. This is also 10 electrons. This is also 10 electrons. Next, see this particular, all the three are carrying the same number of electrons. On same number of electrons, their configuration will be same. Coming to option D, also let us check. Then it is given as what? Beryllium, aluminum plus 3 and Cl plus, aluminum plus 3 and Cl plus. Beryllium you see 4 electrons, 10 electrons, 16 electrons. Then isoelectron species means, iso means same, number of electrons should be same, their configurations are same. We have to see which is carrying same number of electrons. Then here option number 3, question number 4, answer is C. Question number 5, ionic radii of E, titanium plus 4 less than Mn plus 7, B, Cl35, Cl37, C, K plus and Cl minus, D, P plus 3 and P plus 5. See, one thing once you talk about ionic radii, greater the positive charge of the ion, greater the positive charge, greater positive charge over the cation, smaller will be the size. Smaller will be the size. According to this particular concept, let us see. Now we talk about the option A, titanium plus 4, Mn plus 1. See, titanium plus 4 is carrying what? Plus 4 charge. Mn is carrying what? Plus 7 charge. Then Mn plus 7 is actually smaller than titanium plus 4. This is not the correct. Coming to B, chlorine 35 and 37 both are given. Either you take 35 and 37, then both are isotopes. They are neutral atoms, isotopes. Both are having same atomic sizes. Coming to C, K plus is bigger than Cl minus is given. K plus is actually smaller than Cl minus. A cation is smaller, anion is bigger. Therefore, answer C is also not correct. Coming to this particular D, phosphorus plus 3 is given, phosphorus plus 3 and phosphorus plus 5. According to this particular concept, look here, greater the positive charge over the cation, smaller is the size. Here, phosphorus plus 3, phosphorus plus 5. Definitely phosphorus plus is carrying less positive charge than phosphorus plus 5. Therefore, phosphorus plus 3 is bigger than phosphorus plus 5. Therefore, question number 5, answer is D. Question number 6. The IP of an element on going from left to right in a period increases, decreases, remains unchanged. D. Gets double. So generally in a period we are taking in a period. In a period generally left to right IP values increase. Why? Once you are talking about take lithium, beryllium, boron, carbon, nitrogen, oxygen. Then from left to right you are talking about atomic size is decreasing. Atomic size is actually gradually decreasing. 1 point. Next. Electrons are entering into what a same shell. Electrons are entering into same shell. Therefore, and also increase in the nuclear charge. Increase in the nuclear charge. 3 points you have to remember here. One is atomic size is decreasing. Second one, electrons are entering the same shell. Third one, gradually nuclear charge is increasing. Therefore, atoms are slowly contracting from left to right. Once atom is contracting, IP values increase. So, in a period generally from left to right, IP values increase. Therefore, question number 6, answer is A. Question number 7. Aluminum plus T has lower ionic radius than Mg plus 2 ion because Al plus T has lower ionic radius than Mg plus 2 because A magnesium atom has less number of neutrons than aluminum. Aluminum plus T has higher nuclear charge than Mg plus 2. See, electronegativities are different. Aluminum has lower ionization potential than magnesium. Look here now, already given once. Greater the positive charge, positive charge over the cation, smaller will be the size. Greater the positive charge over the cation, smaller will be the size. What is the reason for it? Now we talk about aluminum and again magnesium. What else given this particular aluminum plus 3, Mg plus 2. Greater the charge, smaller the size. Why? The reasons are given as what? Option B, you check it. Aluminum plus A has higher nuclear charge than magnesium plus 2. So this is carrying 13 protons, 10 electrons only. This is carrying 12 protons, 10 electrons only. So both are carrying same number of electrons, we agree. But the nuclear charge, 13 protons. Aluminum plus T is having 13 protons. It is having greater nuclear charge than magnesium plus 2. Therefore, it attracts the outermost orbital electrons toward the nucleus. Therefore, cation with the greater charge will be smaller in size because of nuclear charge dominating the electronic charge. Therefore, question number 7, answer is B. Look here, question number 8. The 4F level is successively filled up in A. Alkali metals, B. Rare gases, C. lanthanides, D. actinides. Alkali metals generally S orbital is actually gradually filling up. It may be 1s1, 2s1 like this S orbital. Coming to rare gases actually the terminal group, that is actually 18th vertical column. The configuration coming to be NS2 NP6 for rare gases. NS2 NP6. The electrons actually enters into this particular S and P orbitals in the case of this rare gases. Talking about this particular lanthanides. Lanthanides also known as what? 4F series we call. Actinides we call it what? 5F series we call. In the case of lanthanides, the differentiating electrons are entering into 4F orbitals. Actinides, the electrons are entering into 5F orbitals. Therefore, 4F series lanthanides. Therefore, question number 8, answer is C. Question number 9. The radii of F minus, F, O, O minus 2 are in the order. Then option A is O2 minus 2 is bigger than F minus, bigger than O and F. O2 minus is bigger than F minus, bigger than F and O. C. F is bigger than O, 2 minus bigger than O minus and F. and O2 minus bigger than O minus F and F minus. See, whenever this particular ions are given, check it. Greater the negative charge over the anion, bigger the size. I will put a statement here. Greater the negative charge bigger the size. Size of anion. Greater the negative charge, bigger the size of anion. According to this particular concept, let us see. What is F minus? F minus F. Next, O minus 2. Whichever is having greater the negative charge, that will be the bigger size I said. Therefore, let us check first. O2 minus should be bigger than F minus. F minus should be bigger than O. O is bigger than F. So, greater the charge over the anion, this is bigger than F minus, but O is bigger than F, I am saying. How? Suppose you talk about second period of elements, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Left to right, you know, atomic sizes are decreasing. Atomic sizes are decreasing. Therefore, in comparison to oxygen, this part of fluorine will be little smaller. Left to right, atomic size is decreasing. So, O and F you talk about, O is little bigger than what? F. Therefore, this is the correct order. Let us see the options. Option A is the correct answer here. O2 minus, F minus, oxygen and F. Therefore, question number 9, answer is A. See question number 10. The correct order of ionization potential values of beryllium, boron, lithium and carbon atoms is. Wherever the ionization potentials are given, check what are their configuration. According to their configuration, their stability of configuration, we can decide the IP values. What are the given actually here? Beryllium, boron, lithium and carbon. Let us put in the order. One is the lithium, beryllium, boron and carbon. The configuration of lithium is what? S1, beryllium carbon is what? S2, this boron carbon is S2P1, this is S2P2. According to order of stability, this is what actually less stable electronic configuration. Therefore, lithium will be, among this particular lithium will be definitely having lower IP value. Lithium is less than this particular beryllium. Lithium is less than beryllium, but beryllium is more than boron. And boron is less than carbon. So, P1 I can easily remove the electron. Therefore, in comparison to this particular boron and carbon, this is atomic number 5, atomic number 6. Left to right IP value is increasing. Therefore, this particular boron is having less than carbon. So, S1 configuration, S2 configuration, P1 configuration and P2 configuration. See, this is what? S1, this is S2, this is P1, this is P2. Therefore, lithium is less than beryllium, beryllium is more than boron, boron is less than carbon. Since boron to carbon IP value is actually increasing because left to right IP value is increasing. Therefore, question number 10, answer is C. See students, question number 11. The ionization energy values of an element are 4 ionization energy values are given. The number of valence electrons in the element are. See, this is very important. Whenever IP values you talk about, first IP you take. First IP to second IP. Suppose a large difference is there, large jump or difference. That will be belonging to first A group. Now, second IP to third IP you talk about. Suppose the large jump is there, large difference there. That will be second A group of element. Similarly, you consider third IP to fourth IP, a large difference is there. That will be definitely 38 group of element we can consider. Once fourth IP to fifth IP you take, that will be successively belonging to, again you can consider fourth A group. This is the general concept that we are talking about. Here the ionization energy values are given, 4 ionization energy values. 191, second IP, what is given? 578, third IP 872, and fourth IP 5692 kilocalories. See, first IP to second IP, a difference is there. Second IP to third IP, a difference is there. But third IP to fourth IP you are talking about, third IP to fourth IP, the difference is large. Nearly it is double, not even double, it is actually many more times greater. 872 and 5692. A large difference is there. Then third IP to fourth IP, the large difference is there. For third IP to fourth IP, large difference is there, that particular belong into what? Third A group. One third A group means first A group carrying 1 valence electron, second A group is carrying 2 valence electrons, third A group is carrying what? 3 valence electrons. Then third IP to fourth IP, large difference is that particular element belonging to third A group carrying 3 valence electrons. Therefore, 11th question, answer is C. Question number 12. An alkali element has the IP values. IP1 and IP2 are given for this particular alkali earth metal. IP1, IP2. What is 9.2 electron volts per atom? Second one is 18.5 electron volts per atom. The first IP and second IP values are given. So the difference about it is double. Yes, almost double the first IP to second IP. Second IP to third IP, a large difference should be there for a second A group of element, because the electronic configuration of second A group element is NS2. Once you are removing the electron, this is what we NS1. You are removing the second electron, this will be what NS0. Removal of electron from this particular NS0 will be very difficult. This is representing what? I1, IP1. This is representing what? IP2. Then IP3 should be very high. The large difference. Let us see the answers. Option A is what? 3 electron volts. B is 154. C is 20. And D is what? 10. The option A is even less than the first IP. And option C is what? 20, near to second IP. And option D is what? Near to first IP. Therefore, there should be a large difference between second IP and third IP. That will be alkali earth metals or second A group of element. Therefore, 12th question answer is what? B. Question number 13. A sudden large jump between the values of second and third ionization energies of element would be associated with which of the following electronic configurations? What is given is large sudden difference of energy there between second and third IP values you saying. Now let me give here second IP, third IP, large difference there. Large difference. Wherever second to third IP large difference is there, that should be belonging to second A group of element. Second to third large MP there, that is what? Second A group of element. Therefore, let us check the answers here. Options 1s2, 2s2, 2p6, 3s1. 3s1 is actually first A group of element. And option B 3s2, 3p1, that will be third A group of element. Coming to C 1s2, 2s2, 2p6, 3s2, this will be what? Second A group of element. Coming to D 1s2, 2s2, 2p6, 3s2, 3p3, that will be belonging to what? Fifth A group of element. Now we consider option 3, it is second A group. 1s2, 2s2, 2p6, 3s2. This will be what? 10 plus 2, this is what magnesium. See students, here second IP to third IP lot difference is there. Suppose the magnesium electronic configuration of the third option is there 1s2, 2s2, 2p6, 3s2, that is representing 12 electrons with the configuration of magnesium. Magnesium, we can easily remove the first electron. See, becoming what? Magnesium plus. Second electron, then it is becoming what? Magnesium plus 2. This is equal to what? Neon electronic configuration. It is representing what? Neon electronic configuration. Removal of the third electron is very difficult. Therefore, what we can consider, wherever second IP to third IP large difference is there, as given the statement, then it should be belonging to what? Secondary group of element. The electronic configuration should be NS2. Therefore, according to the given options, 13th question, answer is C. Why the large difference is there? Once you are removing 2 electrons from magnesium, it is becoming equal to what? Neon electronic configuration, stable neon electronic configuration with the octet electronic configuration. The removal of electron from the octet electronic configuration is difficult. Therefore, question number 13, answer is C. Question number 14. Which one of the following elements has the highest ionization energy? Wherever highest ionization energy is the question, then you see which of the following is having stable electronic configuration. Coming to option A is what? Neon 3s2 3p1 is given. 3s2 3p1, that is 13 electrons, it will be representing what? Aluminum. And neon 3s2 3p2, this will be representing 14 electrons, it will be what? Silicon. It will be silicon with 14 electrons. And C, neon 3s2 3p3, it is representing what? This phosphorus with the 15 electrons. This is what? 13 electrons. Coming to next D, argon 3d10 4s2 4p3. This is representing what? Arsenic. Arsenic with the 33 electrons. Arsenic with 33 electrons. Now we consider this. This is having what? S2p3 configuration. This is also having S2p3 configuration. But phosphorus to arsenic, the size is what? Increasing. Yes, we agree. S2p3 both are having same stable electronic configuration, but comparison to phosphorus, arsenic got bigger in size. Therefore, this particular first IP of this particular phosphorus will be among this is very high. Therefore, which one of the following elements has the highest ionization energy? Therefore, question number 14, answer is C. This is what? Phosphorus. Question number 15, X gaseous state plus electron giving rise to X minus gaseous state plus energy. Here E is what? Whenever electron is added to an element, no, C in the gaseous state, you are adding an electron, then it is becoming what? X minus in the gaseous state plus energy. Here is what? Whenever electron is added to the outermost orbit of the neutral gaseous atom, the energy liberated we call it what? Electron affinity. Therefore, A, first electron affinity, B, first ionization energy, C, second electron affinity, D, second ionization energy. X is becoming simply X minus. This is what? Neutral atom is gaining what? 1 electron, it is gaining what? Only 1 unit of negative charge. Therefore, you are adding only a single electron. The energy liberated will be only first electron affinity we can call. Therefore, question number 15, answer is A. Question number 16, elements of the following group form anions most easily. A, oxygen family, B, nitrogen group, C, halogens, D, alkali metals. Among these options, the seventh group of elements are having what? High electronegativity, high electron affinity. Whichever are having high electronegativity and high electron affinity, they are easily forming the anions. Therefore, question number 16, answer is C. Halogens are easily capable of accepting a electron and converting into anions. Therefore, for question number 16, answer is C. Question number 17. Energy is released during the formation of a hydrogen ion, a oxide ion, a ferrous ion, a ferric ion. See, first one is hydrogen ion. Hydrogen ion is what? H minus. Next, oxide ion O minus 2 and ferrous ion Fe plus 2, ferric ion Fe plus 3. In this, whenever H is converting into H minus, you are adding the electron. H, electron, you are adding what? H minus. In the gaseous state, the energy liberated, we call it what? This electron affinity or energy liberated. But to talk about this particular oxide, then you are adding one electron. Yes, we agree. This particular is becoming O minus. This will be energy liberated. But in the case of O is actually again you are adding electron becoming O minus 2. In this particular case, energy is what? Absorbed. Energy is what? Absorbed. We have to supply energy to O minus. Then you have to push the electron. You have to supply the electron to enter the electron into the O minus. Therefore, conversion of O minus to O minus 2. The second electron affinity of oxygen is always endothermic. First electron affinity is exothermic, but second electron affinity is what? Endothermic. Therefore, in this particular conversion of O to O minus 2, it is absorbing energy. In the case of ferrous ion and ferric ion, ferrous ion means you have to remove the 2 electrons, ferric ion means you have to remove the 3 electrons. Removal of electrons again requiring absorption of energy. Therefore, only the option A, H is converting into H minus. In this particular case only, energy is liberated. Therefore, question number 17, answer is A. Question number 18, electronegativity is the property related to isolated atom in the gaseous state, isolated atom in the solid state, inert gas, bonded atoms in the molecule. Generally, electronegativity we call it what? Property of combined atoms. Electronegativity, property of combined atoms. Electron is the property of combined atoms we consider. Therefore, it is not the property, electron generally is not the property of a isolated or single atom. Therefore, 18th answer is what? D. Question number 19. When a neutral atom is converted into cation, there is decrease in the atomic number, an increase in the atomic number, a decrease in size, an increase in size. Generally, a neutral atom converted into, consider as sodium, converted into what? Na plus. Na plus. Then electron is released. A neutral atom is a little bigger and cation is found to be what? Smaller. Therefore, whenever neutral atom converts into cation, atomic size is decreasing. But it is given the decrease in atomic number. Atomic number equal to number of protons. Therefore, there is no change in the number of protons. Next, increase in the atomic number. There should be increase in the proton number. No. Once only the electron change is taking place in this. Therefore, there is no choice of any decrease in the atomic number or increase in the atomic number. Coming to a decrease in size. Yes, a neutral atom converts into cation, there will be decrease in size. And an increase in size. Whenever neutral atom converts into cation, there will be decrease in size only. There should never be increase in the size whenever neutral atom converts into cation. Therefore, for question number 19, answer is C. Question number 20. Which of the following property does not relate to a neutral gaseous atom? Ionization potential, electron affinity, electronegativity, and both IP and electron affinity. What I said, you see, electronegativity is the property of combined atoms. Electron is the property of combined atoms. Therefore, for question number 20, only the electronegativity. What is given? Property does not relate to a neutral gaseous atom. This electronity is actually combined atoms only. We can compare the electronity, the comparison between the bonded atoms only, which is more electronegative, which is less electronegative. Therefore, question number 20, answer is C. Question number 21, the bond energies of hydrogen and X2 and HX are 104, 60 and 102 kilocalories per mole. The electron of hydrogen is 2.1, then the electron of X is. If you have to calculate here the electron of halogen or the X. According to Pauling scale, this is the whenever energy is given in the kilocalories per mole, bond energy is given in the kilocalories per mole, then we have to apply this particular equation. Then chi A minus chi B, that means electron of A minus electron of B is equal to 0.208 bond energy of HX minus bond energy of hydrogen into bond energy of halogen, the power half and whole power half. Now you substitute all these values and calculate, then you will be getting definitely the electronegativity of X, most probably it may be chlorine, then you are getting the chi X, the electronegativity of X is 3 you are getting. You calculate and check according to this particular equation. Therefore, question number 21, answer is C. Question number 22, which of the following electron configuration corresponds to the most electropositive character? Most electropositive character means you can take first A group of element. The electronic configuration should be NS1. Electronic configuration should be NS1. This we can consider the most electropositive. Let us see the answers now. Helium 2s1 is given, helium 2s2 is given, xenon 6s1 is given, xenon 6s2 is given. We have to choose among these wherever NS1 configuration that is the most electropositive. But option A is given as what? 2s1. Option A is given as what? 2s1. Option B is given as what? 2s2. Option C is given as what? 6s1. Option D is given as what? 6s2. 6s2. This particular option 1 represents first A group. This is what? Second A group. This is also second A group. This is also first A group. Most electropositive elements are actually first A group of elements. Most electropositive among all the elements in the periodic table. Then 2s1 and 6s1. 6s1 is not very big in size. Then this particular 2s1. 2s1 actually representing this what? Lithium. 6s1 representing it is what? Cesium. Representing cesium. Therefore, cesium is the most electropositive we can consider. Therefore, question number 22 answer is C. Question number 23, which has most stable +2 oxidation state among these which is having +2 oxidation. One is given as cesium, chlorine, lead and thallium. Cesium, chlorine, lead, thallium. Cesium always exhibits first A group of element +1 only. Chlorine actually most common oxidation number of this particular chlorine is what? 7th A group. Then it is always forming the uni-negative anion Cl-, most stable. Coming to lead, lead actually belonging to 4th A group, we agree. 4th A group, we agree. But because of inert pair effect, this is exhibiting what? A stable +2 oxidation state. Lead we know. Lead has to exhibit +4, but because of inert pair effect, it is exhibiting only +2 oxidation state. Coming to thallium, thallium belongs to what? 3rd A group. Yes, 3rd A group. It has to exhibit +3 oxidation state, but commonly our stable oxidation state is only +1. These two, lead and thallium, are exhibiting +2 and +1 stable oxidation states. Our question is, which of the following exhibits stable +2 oxidation state? Therefore, answer is 4th A. Lead has to exhibit +4, but because of inert pair effect, lead +2 is the most stable oxidation state. Therefore, question number 23, answer is C. Question number 24, the outermost shell of representative element contains A electrons and penultimate shell containing B electrons. The valency of the element will be, A representative element. A representative element, it may be S block or it may be P block. It may be S block of element or P block of element, representing what this representative elements, S block or P block. And outermost number of electrons are, let us see three shells we write, first shell, second shell, third shell. Let me write. Outermost number of electrons are, outermost electrons are A electrons and the penultimate shell electrons are B electrons. Penultimate shell is actually carrying B electron. This is only for representative elements. Whatever the number of electrons are there in the valence shell, that will be the valence of that particular element. Therefore, A plus B is given. Option A is A plus B. That is not correct. Coming to B, B minus A. No. Coming to C, B. B means what? Penultimate shell electrons. Only valence shell electrons we consider the what? Valency. Question number 24. This D is given as what? A. Whatever the number of electrons are there in the valence shell, that will be considered as what? Valence of that particular element. Therefore, question number 24, answer is D. Question number 25. An element has 9 positive charges. 9 positive charges. In its nucleus, its common oxygen state is 9 positive charges means number of protons are 9. 9 positive charges equal to number of protons equal to 9. Equal to what? Z, nothing but atomic number. 9 positive charges, 9 protons, then that will be having the atomic number 9. 9 atomic number is fluorine. Let us see the answers now. Option A is what? Plus 7. Option B is what? Plus 5. Option C is what? Minus 1. Option D is what? Plus 1. It is fluorine, nothing but fluorine. Fluorine always exhibit a common oxygen state of minus 1 only. Therefore, question number 25, answer is C. Question number 26. In the given reaction, the oxide of sodium is, the given reaction, the oxide of sodium is 4Na plus O2, 2Na2O, Na2O plus H2O, 2NaOH. A is acidic, B is basic, C is amphoteric, D is neutral. Let us see the what equation is given. 4Na, sodium in the air, then you are getting sodium monoxide. This particular sodium monoxide, Na2O plus treated with water. Water. You are getting what here? Sodium hydroxide. Sodium hydroxide, well known to us, it is actually basic compound, it is basic in nature. That way solution of sodium hydroxide is perfectly a basic. Therefore, 26th answer is B. Look here, question number 27. Considering the chemical properties, atomic weight of beryllium was corrected based on electronic configuration, B valency, C atomic number, D 2 and 3 are given. Both B and C is given. The atomic number of particular element can be corrected only based on valency. Therefore, based on this particular beryllium valency, according to its chemical properties, beryllium atomic number, atomic weight corrected only based on valency of this particular beryllium and based on its chemical properties. Therefore, question number 27, answer is B. Question number 28. Which of the following pairs of ions have the same electronic configuration? Means isoelectron. Let us see the options. A is what? Chromium plus 3, Fe plus 3. Option B is what? Fe plus 3, Mn plus 2. Option C, Fe plus 3, cobalt plus 3. Option D is scandium plus 3, chromium plus 3. So, which of the following pairs have the same electronic configuration? Same electronic configuration means there should be same number of electrons. Same number of electrons. Let us see in this particular pairs which is having same number of electrons. Coming to chromium plus 3, it is actually 24. 24 minus 3 equal to 21. Iron, it is actually 26. 26 minus 3 equal to 23. They are not having the same number of electrons. They are not isoelectron. Coming to iron, it is what Fe plus 3 we already taken here. This is having what 23 electrons. Fe plus 3. Mn, you know, 25 atomic number minus 2 23. See this particular Fe plus 3 and Mn plus 2 are having same number of electrons. When their number of electrons are same, their electronic configuration will be same. The question is, which of the following pair is having same number of electrons and what is same electronic configuration? Your question number 28, actually answer is what B. But let us see C and D also. Now we consider Fe plus 3, just we have taken it is what 23, right? Cobalt atomic number is what 27. 27 minus 3, it is what 24. Scandium is actually 21. 21 minus 3 means what 18. And chromium, it is already we have taken, this is coming to what again 21. 21. See this particular option B, these two Fe plus 3 and Mn plus 2, these are having same number of electrons. The electronic configuration will be same. For this you have to remember at least all the 3D elements so that you can easily answer this type of questions. This type of questions are repeatedly appearing in the different entrance exams. So question number 28, answer is B. Question number 29, O minus 2 and silicon plus 4 are isoelectronic ions having what same electronic configuration. If the ionic radius of O minus 2 is 1 angstrom, the ionic radius of silicon plus 4 will be, See one is given as O minus 2, other is given as what? Silicon plus 4. Now, O minus 2 is silicon isoelectronic, ionic radius of O minus 2 is 1 angstrom is given, 1 angstrom. What is the ionic radius of this particular silicon plus 4? Yes, one isoelectron species is there, this is the anion, this is the cation. Moreover, tetrapositive cation, that is, this is very small in size in comparison to O minus 2. Coming to option A is given as what 1.4. How can it be bigger? No, it should not be bigger than this particular, this one 1.4 angstrom. This is not correct. Coming to option B, 0.41 angstroms. 0.41 angstroms, it is very small in size in comparison to this particular oxygen. Coming to option C, 2.8 angstroms. Option D, 1.5 angstroms. Whatever it may be, this is what a di-negative anion, the tetrapositive cation. The positive cation should be definitely smaller than the anion in this particular case. Therefore, question number 29, smaller size 0.41 angstroms. Therefore, question number 29, answer is B.